Hey guys, so today we're going to check out the conic sections. So a conic section is just a part of the cone, and we have a few of them we're going to look at. First part is the circle. So if we cut a cone parallel to its base, that's going to produce a circle. Doesn't matter how far up or down the cone we go, it's going to make a circle that's parallel to that base. Now, you know a circle is a set of points equidistant from a center point. That distance is called the radius. You should all be very familiar too from geometry. Now we represent the center as HK and the radius as R. This is the standard form of the circle. You will need to memorize that. We're going to focus on the circle today, but let's go ahead and look at the other conic sections. Now, if we're not quite parallel to the base, if we're going at an angle, instead of a circle, that will form an ellipse. No, that is not an oval. There's no such thing as an oval. Don't say oval. It's an ellipse. And instead of a center, really, for the ellipse, we're worried about the two foci here. We form the ellipse with the foci. Yes, it does have a center point, but that's not as useful as the two foci. We form it with these foci. And we have two different formulas here, depending on if it's horizontal or vertical ellipse. Next up, we have, well, let me go to this one first, the parabola. So this guy you should recognize from Algebra 1, Algebra 2, this year earlier. You know, we've done the parabola. We've done them a lot. That's your quadratic, ax squared plus bx plus c equals 0. However, here, we're going to look at them slightly differently because we're not necessarily looking at a parabola as a function because we could have a sideways parabola. We're looking at them as the conic section, that geometric shape. So just because it's not a function doesn't mean it's bad. We're going to look at it. Okay, so it's pretty much the same thing you're used to dealing with. The formula looks slightly different, but it is exactly the same thing. Now let's go back to that hyperbola. So this kind of looks like two parabolas, either side to side or one on top of the other. And it's made from two cones on top of each other, nose to nose. If we go perpendicular to that base, it's going to form a hyperbola. Now, there is a general form for all conic sections that we're going to look at so we can use to see what kind of conic section is it going to be. But these are the standard forms here. So once we rearrange it in the standard form, we'll see, oh, this is the type of function or the type of shape we're dealing with. Because none of these are functions except maybe the parabola sometimes. So let's get into the circle. All right, again, here's the conic sections. It's also good to note that if we cut it just the tip of the cone, that would be a point. Not very useful, but it's there. Also, we could make a line if we cut just the edge of that cone. We could have a plane going through that, and that would form a line. Points and lines aren't that interesting, though, so we're going to go with these guys. So again, if it's parallel to the base, that forms a circle. If it's at an angle, that's going to form an ellipse. This right here would be a parabola and a hyperbola. Not to be confused with hyperbole. This is not English, it's math. All right, so circles. Today is all about circles. This standard form of a circle. So it's going to be x minus h squared plus y minus k squared equal to r squared. And it is right here also, if you can't read my handwriting or whatever. There you go, magic. Now, HK is the center. R is the radius. Notice that this is x minus h, and this is y minus k. Well, remember how whenever we're dealing with those other functions, if we were subtracting with the x, we had to do the opposite. We had to go to the right to the left. Exact same thing here. But since both of these are being squared, it's not y equals, it's a number. We have to do the same thing for the horizontal and vertical shifts. So that's going to shift horizontally, that's going to shift vertically, and that will produce our center. And it is equal to r squared, not r. So just remember, whatever's over here square root it to get your radius. So let's just practice writing it out. So here we go. That's h, that's k, that's r. So that'd be x minus a negative 4, so that's x plus 4. You could take it just a second step and simplify it there, but I'm just going to go ahead and write it out. Y minus 6 squared equals 4 squared, which is 16. Easy. Now this one I will do in 2 steps, just so you can see. X minus 0 squared plus y, you could say minus a negative 2 squared. Yes, you could take care of this all in the first step and only step. And I'll just say 7 squared. So you could do this. You could write it out and then simplify it. X minus 0, well, that's just x. X squared is x squared. Imagine that. Y minus a negative 2, that's y plus 2 squared equals 49. Now, don't go distributing and combining like terms and everything. This is the standard form of a circle. If you distribute and rearrange it, that's going to produce the general form of a conic section, which we don't want to do yet. All right, here we go. Center is 1, negative 5, so that's x minus 1 squared, y plus 5 squared. And if we square a square root, they cancel, so that's just going to be a 10 right there. Okay. And this one, x minus 9 squared, y minus nothing is just y squared. This one, you might be able to do in your head. You might not. It's going to be 25 times 375. Or just take your calculator, use some frequent parentheses. So if you don't, it will mess up because it does order of operations. So you have to tell it what to square. 75. Whereas if you drop off those parentheses, it's going to read that as 5 times the square root of 3 squared, which would be 15. So make absolute certain you have that those parentheses on there if you have more than one thing being squared, even if it's negative. So that's equal to 75%. Not too bad, right? That's pretty easy stuff. Now, of course, it's not always going to be that easy. Sometimes I might have a graph. We have to figure out what's my center. 1, 2, 3. 1, 2, 3, 4. That's -3, -4 for my center. Radius. How do I figure out the radius? What is the radius? The radius is the distance from the center to the edge of the circle, right? So if I just go right here, that's, I have no idea how long. You need to go up, down, left, or right. Your choice. Pick one. 1, 2. Radius is 2. That's it. So now, x plus 3 squared, y plus 4 squared equal to 4. Same thing on this one. My center is 0, 1. I'm going to count 1, 2, 3, 4, 5, 6. That's going to be just x squared plus y minus 1 squared equals 6 squared, which is 36. Not too bad still. But what if instead of, given the center of the radius, what if they give us some points on the circle? Well, we're going to figure out how to deal with those in a minute. So we have to first remind ourselves of a couple of formulas from the past. The distance formula. If you remember it, we will need it. It's basically just the Pythagorean theorem. The difference in your x's, so a would be the difference in your x's squared plus b would be the difference in your y's squared. And some people, usually put it as x2 minus x1. You can also put x1 minus x2. It makes no difference as long as you subtract your 2 x's and you subtract your 2 y's and follow the formula, you're good. But if you're looking on a graph, say, The difference in your x's will be right here, so that'll be your a. The difference in your y's will be right here. That'll be your b. And to get c, it's a squared plus b squared equals c squared. So to undo that, you square root it. Hence the distance formula. Midpoint formula is the point in the middle. Average them, add them up, and divide by 2. That's literally what you do. So x1 plus x2 divided by 2. That's going to give you the middle of your x's. y1 plus y2 over 2. It's going to give you the middle of your y's. That's your midpoint. We're going to need both of these guys as we go along. All right. So if we're looking at this kind of situation, we got the center and one endpoint on the circle. So any point on the circle, really. Any point on the circle. Doesn't matter. We got the center and the endpoint, we can figure it out. So we got the center already, so we already know it's going to be x plus 2 squared plus y minus 6 squared. What we don't know is the radius. We don't know what it equals. For that, we're going to use the distance formula. That's going to be -2 minus -4 squared. Yes, you could do -4 minus -2, same result. Plus 6 minus 12 squared. Whatever order you do it in, like you start with this point, then start with that point. It doesn't matter to me which one you start with, as long as you start with the same one. And in this particular instance, with the distance formula, it wouldn't even matter if you switch the points around. It does for your slope, but not for your distance. So let's type this in the calculator and see what it spits out. -2 minus -4 squared plus 6 minus 12 squared, and it's 2 square roots of 10. Whatever. Do we care? Not really. What are we interested in? R is 2 square roots of 10, but that's not what we need, is it? In order to get the equation, we need r squared, so we just square that, and we get 40. Boom. Same thing here. So I'm actually just going to type it in the calculator. So writing it out, it's the distance formula. When you practice with that, go practice. So -4 minus -1 squared plus -7 minus -5 squared. We give us square root of 13. If we square that, we get 13. So it's going to be x plus 4 squared, y plus 7 squared equal to 13. I'd appreciate it if on the test you wrote this step out at least, just plugging in the numbers. But you really shouldn't need any practice on that. It's just plugging numbers into a formula. You do need to know the formula, but other than that, it should be good. And this one, same thing. We get 85, we do that. So it's, well, that's going to be just x squared, right? Plus y minus 4 squared, and then that's 49, that's 6, 36 and 49, make 85. We can work it out if you really want to. 0 minus 7 squared plus 4 minus -2 squared. Gives us square root of 85. Square that, you get 85. Yay. And same thing here. X minus 3. Y plus 3. And then Let's see what that spits out. It's going to be a rather large number. 3 minus -4 squared plus negative 3 is 10 squared. And we get 218. Well, square root 218, so 218 is our, well, what's equal to the square of the radius. Easy stuff, right? Not too bad. From there, we can also go with, what if we have 2 endpoints of the diameter? Now for this one, for these 4, we had the center and a point on the circle. We can use any point on the circle, doesn't matter at all. But if we have 2 points in the circle and not the center, they have to be diameter. They have to form a diameter. If you're not, well, then you can't do it. If it just makes a chord, ain't happening. But if we have endpoints of a diameter, then the middle of that will be your center, and it's going to be twice the radius, so you calculate the distance and cut it in half, right? Or you could just find the center and calculate the distance there. Your choice. I'll do it both ways. I'll do this one way, that one the other way. No idea if I'm going to show you yet. Let's just do it. So first thing I like to do is find my center. So I'll write out the formula this one time, but then the rest of the time it's going to be just calculator or head. You add up your x's and divide by 2. You add up your y's, and you divide by 2. That's going to be -1 plus 5 is 4 over 2, which is 2. 14 over 2, which is 7. That's my center. In the middle of the diameter, so that's the center. That's a C colon. It's not if it's shoot along, but yeah, that's center. For the distance, on this one, I'll go ahead and do the whole distance of the diameter. So I use these 2 points they gave me. If I type that in the calculator, it spits out 2 square roots of 10. Now that is my diameter. That's not my radius. So if I divide that by 2, that's going to be my radius. So I square that. It's got to equal 10. So from here, I know my formula. X minus 2 squared plus y minus 7 squared equals 10. Now, another way you could have done it, instead of using the diameter and dividing it by 2, we could have just did the center to either one of the endpoints. Can I go back? No. Unfortunate. I can't. Cool. So let's change the first point to the center point. See what happens. So all I did was I went back and I changed -1, 8 to 2, 7. 2, 7. Let's see. And I get square root of 10. As it is from my center to my endpoint, so that is my radius. Just like we got here, except we did the whole distance and we cut it in half. Same thing. Either way you do it, your choice. So again, we're going to average these. So that center is going to be at -4, 0. I added those up. I got -8 divided by 2 is -4. 0 divided by 2 is 0. Distance. Use a calculator. I'm going to go, I use these 2 points because there's zeros in here. So actually, I can probably do that on my head. That's 16 plus 9 is 25. So, well, it's going to be 25, but the radius is going to be 5. If you don't believe me, let's just do it. 0 minus -4 squared plus -3 minus 0 squared. That should give me 5. It does. So my radius is 5. That means it's going to be equal to 5 squared, which is 25. It just says good the equation, so we don't need to worry about what the radius is. Oops, that's supposed to be next. X plus 4 squared plus y squared equals 25. All right. 2 more. Let's just finish them off. If I average those, I get -1 and 7. That's my center. -4 plus 2 is -2 divided by 2 is -1. 10 plus 4 is 14 divided by 2 is 7. For the radius, not doing that one in my head. -4 minus 2 squared plus 10 minus 4 squared gives us 6 square roots of 2. Again, we don't really care. We need the square of that, which is 72. So x plus 1 squared plus y minus 7 squared equals 72. Last one. -15. And then that's going to be -15 again. Okay. Let's see, that's 4 plus 16. So it's going to equal 20. So it should be this. I'll check in the calculator in a minute. Very easily screw up in my head, so let's just not rely on my head and use the calculator. So, and yes, if you're thinking about it, why don't I just do this? It'll work just fine. Go for it. And again, for the distance, I'm going to go ahead and go with the center in one of those points. Did I do that on the last one? I don't remember. Let me check. I didn't, so we need to divide that by 2 and square it, so 36. No. Sorry, give me a moment. So 6 square roots of 2, divide that by 2 and square it. Sorry, I had used the center, I did not. So make sure you pay attention. There. This one, yeah, I did that one both ways. This one, I know I did the center and that end point. This one, when I was thinking about it, I was like, oh wait, I did these points, so I did divide by 2. Make sure if you use the diameter end point, you divide by 2. Otherwise, you mess up like I did. So I also messed up this one. That's not going to count. Let's just use the center and that guy. So that's going to be 1 plus 4 is 5. So I'm going to start with my center to make sure I don't forget to use it. The square root of 5, square that, we do get 5. Must like me. Do it right the first time. But yeah, that's the basics of circles and their equations. Nothing really tricky, just make sure you pay attention to what you're doing and don't forget to divide by 2 if you use the 2 endpoints of the diameter. But yeah, that's all there is to it. See you guys.